So, hi everybody, my name is Łukasz Wiszniewski. I work at Center on Informatics, Tri-City Academic Supercomputer and Network, called CI-TASK, which is located at Gdańsk University of Technology. Today I would like to say a few words about our works under the problem of monitoring vast spaces in the cloud edge ecosystem. My presentation will take 5 major steps. I would like to say what the challenge we faced, what we had an opportunity, what was our vision and ambition, and how we came from the concept to reality. And in the end, I am open for any questions from you. First, what the challenge we faced. Gdańsk is located like Amsterdam near the sea, not the Northern Sea, but the Baltic Sea. Gdańsk area is combined with 3 major cities, Gdańsk, Gdynia, Sopot, and it's located near the Gdańsk Bay area. This place cover over 6,500 square kilometers. It has a large metropolitan center with over 1 million people, and it also covers a large industry center, especially a very critical one, which is very important nowadays. According to the war in Ukraine, we have here all refinery, shipyards and seaports. Near there are very numerous small localities, especially farming and tourism. And the last important thing, for many researchers, this is the most important thing, there are located unique nature requiring protection, like famous Baltic beaches, lakes, forests, and rivers. What we have opportunity in our institution, there is located a task cloud. It's an infrastructure as a service with capability of over 250 nodes. Also high power and high power computing and big data analytics capability, including 13 petaflops of processing power and 100 petabytes of data storage. Also our institution meets topmost security requirements of tier 3 and tier 4. What was our vision? Our vision was to insight measurements of raw data using constrained but cheap and disposable and devices places in remote and very hard to reach sites with no telecommunication infrastructure. For example, in the center of the sea. We decided to create a nomadic gateway, which acting as a mobile edge, which can be moved with sailing yacht or flying drone or sailing drone on the places where devices are located, and collect data from them. Data collected from devices can be used in highly scalable cloud computing servers and storage resources for implementing the analytics, for example, with machine learning models. How we came from concept to reality. Firstly, we started with simple, let's say, device. It also contains sensors, battery, power management, PV cells, of course, processor, and the most important thing, the code. our code in devices acts slightly different than we used to know, because the device is storing reads from the environment and wait for the gateway when it will be allowed to send them to the internet. The second element of our research were to build a nomadic gateway. We called it a edge gateway. We tested two approaches. First approach was a normal standard gateway equipped with GSM modem, which allows devices connect through them to the internet. The second approach was to create a gateway which is fitted with the things stack software on it, and it acts like a normal TTN network without need of connectivity to the real, let's say, internet. Data collected from devices are stored in our cloud computing platform. The platform contains databases, both standard and time series, any machine learning models implemented on it, and it's ready for the end user to further analysis. How we started, how we tested. First of all, we started with standard gateways located in the highest point in the Tri-City area with very sensitive antennas, and using sailing yacht and equipped with LoRaWAN devices. We tested how long we can reach our range. As you can see in this map, it's over 40 kilometers. Then we built three prototype sensors. First was the water sensor. It's a simple buoy located in the sea, which can gather information about temperature of water and sunshine according to the voltage of PV cells. The second prototype device was a soil sensor. It is located in a farm, in a field nearby to city area, and it's collecting data about soil itself, so temperature, pH, humidity, and also according to the data from PV cell, we can extrapolate the amount of sunshine. The last type of sensor was an air sensor with sensors for measuring air pollution. As you can know, in Poland, smog problem is a big stuff, so we also started to measuring. We tested our nomadic gateway both in sailing yacht, both in unmanned air vehicles. For this time it was remote controlled airplane, and we made some test runs nearby those devices to collect data from them. What we have done already, so we test coverage of LoRaWAN network in maritime environment, as I show you on the previous slide. Now we are working at a project called Rural IoT. It is an international project between Polish and German institutes, both scientific and private companies. The main goal of this project is harvesting, farm, forest, soil parameters, cleaning them, classification, and use for prediction for future times. This project also uses data fusion from many sources. First source was devices using LoRaWAN fitted in the ground, but also it used data from aerial and satellite and meteorological institutes. Our work ahead is collaborative learning as a service for deploying ecosystems of smart devices at Task Cloud. And the next project we are starting in the nearby future is preventing maintenance of offshore wind farms. It is a European Union grant. So thank you for your attention. If you have any questions, I will be pleased to answer them.